So yeah, robots can dance, they can walk around, they can interact. I think we're headed to a radically different world.
Your companion, it can be at your house, it can sort of babysit your kids, it could teach them, be a teacher.
Elon Musk has just unveiled Tesla Optimus Gen 3, an astonishing humanoid robot that's not only intelligent, but a blazing fast self-learning machine. Picture this, a robot mastering 1,000 new skills every single day, using nothing but Wi-Fi and YouTube. With its sleek design, powerful AI, and a price tag under $20,000, it's poised to revolutionize elder care by offering not just support, but real independence. The Tesla bot is no longer a concept. It's a rapidly evolving, cost-effective reality that may soon redefine how we live, work, and age. The future? It's already here, staring us in the face. But the real question is, are we truly ready to live alongside a machine that might someday outlearn us all? Or are you panicking, worried these robots will steal human jobs? Take a breath, because in today's episode of Tesla Car World, we're breaking down all the thoughts racing through your mind. Mention the words humanoid robot, and you'll likely trigger a wave of mixed reactions. For some, it sparks visions of a sleek, tech-driven future where machines handle everything from dangerous jobs to the tedious chores we love to hate: cooking, cleaning, maybe even folding laundry. It's the ultimate convenience fantasy, but not everyone's excited. In fact, a lot of people are uneasy, worried that these robots will edge humans out of the workforce, or worse, spiral into some dystopian scenario right out of a sci-fi thriller. Then there's the camp that just can't take these machines seriously. To them, most humanoid robots still seem clumsy, overpriced, and stuck in the uncanny valley, like someone tried to build a human out of spare parts and forgot to update the software. Comparisons to politicians or tipsy pedestrians aren't uncommon, and honestly, they're not entirely off base. Let's be clear, we're not saying Tesla has the most advanced robot on Earth. But when it comes to practical potential, robots that might actually help regular people live better lives, Optimus is leading the pack. It's not just powerful, it's within reach for more people than ever before, thanks to a price tag that makes home robotics a real conversation, not just a dream.
Well, I think the cost is actually not going to be crazy high, like less than a car.
Fundamentally, at scale, the Optimus robot, you should be able to buy an Optimus robot for, I think, probably $20,000 to $30,000 long term.
Elon Musk aims to make life easier for older adults who are struggling with the rising costs and inefficiencies of traditional caregiving. With an expected price tag of under $20,000, the Tesla bot isn't just an affordable option. It's a reliable companion that helps seniors stay safe and independent in their daily lives. So why can Tesla Bot Gen 3 learn over 1,000 skills per day?
Optimus can watch videos, YouTube videos or how-to videos or whatever, and based on that video, just like a human can, learn how to do that thing. Then you really have task extensibility that is dramatic, because then it can learn anything very quickly.
Recently, Tesla released a new demo video showcasing the impressive capabilities of Optimus as it performed a variety of new tasks, further reinforcing its potential as a valuable household assistant. The video sparked excitement and anticipation for the official launch of Optimus. In this latest showcase, Optimus completed common domestic chores like sweeping, vacuuming, and cooking simple meals. It used a microwave, picked up trash, and even cleaned with precision. The demo didn't stop at home life. The robot also handled industrial tasks like picking up automotive parts in a factory setting, signaling its ability to serve both households and production lines. What's most striking about Optimus's behavior is its simplicity. Rather than relying on a long series of coded commands, Optimus only needs a single voice instruction, such as pick up the broom and sweep the floor, to understand the task and complete it from beginning to end. It doesn't need a script. Just tell it what to do in plain language, and it takes care of the rest. Another standout capability is its two-handed coordination, a feature that marks a major leap from its earlier versions. Past iterations of Optimus mostly used one hand for basic tasks. Now it can fluidly use both hands in sync, allowing for far more complex human-like actions. Behind the scenes, its neural network is calculating real-time motion, paths, avoiding collisions, and maintaining balance. Optimus's dexterity is supported by Tesla's custom hardware. Each hand has 22 degrees of freedom, allowing for nuanced manipulation of tools and objects. This gives it a huge advantage over other robots, whose mechanical limbs are often too rigid or simplistic to perform useful real-world tasks. But Tesla isn't just innovating in robotics hardware, it's revolutionizing how robots learn. Most robots are trained using motion capture or remote control methods. Tesla is taking a more scalable and intelligent approach, letting Optimus learn by watching videos of humans. If this sounds a bit like how people use YouTube tutorials to learn how to fix a sink or cook a dish, that's the idea. Optimus can watch a video of someone stirring a pot, folding laundry, or cooking a steak, then recreate those motions in a virtual environment, practicing them billions of times in simulation. When it reaches near-perfect execution, it's deployed to the real world. This form of self-learning through simulation allows Optimus to acquire new tasks much faster and more efficiently than with traditional methods, and it gets even more impressive. Tesla has created a centralized intelligence system. This means that when one Optimus learns a task, say, making an omelet, that knowledge is instantly available to every other Optimus robot on the planet. There's no need to retrain each robot individually. The system is modeled after Tesla's success with autonomous driving AI, which has collected insights from billions of miles of road data to improve vehicle decision-making. As Elon Musk explained,
It's got the real-world AI. So Tesla's the leader in real-world AI. What we learned in the car, we translate to the Optimus robot. And we also take our expertise in electric motors, in batteries, power electronics, structural design. And then another major important thing is that we're very good at manufacturing.
this manufacturing advantage is what makes Optimus different. While most robots are built in limited numbers for research labs or exhibitions, Tesla is preparing Optimus for mass production. That changes everything. As the number of deployed units grows, so does the collective intelligence of the entire Optimus network. In industrial settings, this centralized system creates massive efficiency. If one Optimus robot learns how to assemble a component for Tesla's Cybercab robotaxi, that process is shared instantly across the factory floor. With potentially thousands of robots learning and sharing simultaneously, Tesla could build a library of millions of distinct tasks in just a year. In homes, that same intelligence makes Optimus a powerful personal assistant. From vacuuming and wiping surfaces to drawing curtains and serving drinks, Optimus can become an all-in-one helper, adapting to the needs of individual users and learning new tasks on the fly. Some might question whether Optimus is learning real skills or just mimicking motion. But Tesla's learning model is based on error correction at scale, something even human experts can't replicate. While 1,000 chefs might learn how to cook a steak with varying results, one Optimus can perfect the technique in simulation, then distribute that perfect method to every other unit. This level of accuracy and consistency could make Optimus indispensable, not just as a cleaner or cook, but eventually in fields like elderly care, logistics, or healthcare, where precision and safety are paramount. Musk has called Optimus potentially the biggest product of all the time for Tesla, even bigger than electric vehicles. Given its adaptability, collaborative intelligence, and manufacturing readiness, that prediction doesn't seem far-fetched. We're witnessing the early stages of a robotics revolution that could transform how we live and work. For now, Optimus Gen 3 is still evolving. It's not yet flipping pancakes with style or babysitting toddlers, but its core strengths are already clear. It learns fast, shares knowledge instantly, performs tasks reliably, and improves continuously. Whether in a home, a warehouse, or a factory floor, Optimus is poised to be more than just a robot. It's the future of intelligent, scalable assistance. And with Tesla leading the way in real-world AI, manufacturing, and robotics, that future may arrive sooner than we think. So, how long can a Tesla bot Optimus be used? Tesla's Optimus Gen 3 isn't just a leap in robotics, it's a commitment to long-term performance and sustainability. While many commercial robots are designed to last between 5 and 10 years, Tesla is setting a far more ambitious standard. Optimus is built to operate reliably for up to 24 years under real-world conditions, without the need for major overhauls. This impressive lifespan isn't just a marketing claim. It's the result of meticulous engineering across every component: structural, mechanical, electronic, and digital. From aerospace-grade materials to advanced AI and battery systems, Optimus reflects Elon Musk's goal of creating a robot that not only works, but keeps working for decades. Let's start with the robot's physical core. Optimus's skeleton is made from 7075-T6 aluminum alloy, a material prized in aviation and aerospace for its exceptional strength-to-weight ratio. With tensile strength around 83,000 pounds per square inch, this alloy ensures the frame can withstand daily physical stress over decades of movement, lifting, and fine motor activities. For the robot's most vulnerable joints, such as the shoulders, knees, and spine, Tesla uses carbon fiber reinforced polymer, CFRP. It's lightweight, strong, and impact-resistant, helping the robot maintain agility while withstanding sudden impacts. Unlike heavier metals like titanium, used in some rival robots, CFRP allows Optimus to stay nimble and power-efficient over a long lifespan. Internal mechanics are equally future-proofed. All joints and moving parts are built for high cycle endurance. Tesla stress tests each major joint with 1.5 million full flex cycles, simulating more than 20 years of typical use in environments like homes, warehouses, and manufacturing floors. The gearboxes run on high-grade synthetic lubricants and stainless steel bearings, while the motors feature thermal shielding and intelligent load balancing to prevent overheating. The energy system is another critical part of this 24-year goal. Optimus is powered by Tesla's in-house 4680 battery cells, optimized for long lifespan and stable output. These cells have shown in lab simulations the ability to retain over 80% capacity after 3,500 full charge cycles. Assuming Optimus works 6 days a week with 1 full charge per day, that's more than 20 years of operation, and potentially 24 years with intelligent power management and partial cycle optimization. Tesla's battery management software adds another layer of durability. It features adaptive charging algorithms that regulate temperature and prevent long-term chemical wear. By limiting high-stress conditions like full discharges and overcharging, the system can stretch the battery's practical life beyond typical industry expectations. But raw power and materials aren't enough. What sets Optimus apart is its intelligent self-preservation. The robot's neural network, adapted from Tesla's full self-driving AI, allows it to detect wear or irregular force in any limb and make real-time adjustments. If a joint starts experiencing abnormal torque, Optimus can reduce its load and redistribute effort to other joints, protecting its own hardware from long-term degradation. This smart behavior extends to thermal and motion control, helping Optimus remain cool and balanced, even during long workdays. The robot also includes modular architecture, allowing users to replace individual parts, motors, sensors, actuators, without needing to dismantle the entire system. This not only saves on maintenance costs, but extends the overall life of the unit by making minor repairs instead of full replacements. To ensure it holds up over the decades, Tesla puts Optimus through extreme stress testing. Temperature swings from -25 degrees Celsius to 50 degrees Celsius, drop tests, vibration tests, and dust chamber simulations. The company also runs digital twins of the robot through tens of thousands of simulated operating hours, identifying potential weak points well before production. Even sensor arrays, such as vision cameras, torque sensors, and gyros, feature redundancies, ensuring the robot remains functional even if a module fails. This keeps Optimus active without costly downtime, adding years of usable life across its deployment cycle. Looking at Tesla's track record, this kind of long-term durability isn't new. Many early Tesla Roadsters released over 15 years ago are still on the road, running on their original drive units and batteries. The same dedication to hardware and software resilience is now being translated into robotics. When you combine Optimus's structural strength, intelligent learning, self-regulation, and shared AI system, the result is more than just a useful machine. It's a reliable coworker that improves over time and remains valuable for 2 full decades and beyond. So, in under 2 years, how Tesla just made every other humanoid robot obsolete. Most humanoid robots today exist more as lab experiments than functional tools. We've seen countless flashy videos, robots performing backflips, dancing, or doing menial tasks, but most disappear without making it to market. The reality is they're not built for scale, nor are they designed to integrate into everyday life. Many are simply high-tech prototypes that never leave the lab. In a bold move that flipped expectations, Tesla brought 50 fully functional Optimus Gen 3 bots to a major live event, originally planned to showcase their Cybercab autonomous taxi. But instead of all eyes on the vehicle, it was the Optimus robots that stole the spotlight. Attendees gathered around them, interacted with them, and for many, this marked the first time a humanoid robot actually felt real, reliable, approachable, and practical. This advanced humanoid robot can inspect and receive deliveries, serve drinks, fold laundry, and clean the kitchen with ease. At a target retail price of $20,000, Tesla is aiming for mass adoption. Thanks to in-house manufacturing and shared parts with Tesla vehicles, especially the 4680 battery, production costs are estimated around $10,000 per unit. This allows Tesla to sell at a price point no other company in the space can currently touch. At that price, Optimus becomes accessible to households, small businesses, and institutions, moving the humanoid robot from fantasy to functional reality. And if you're still wondering whether this is just another overhyped product, remember, Tesla has a track record. From electric vehicles to solar to battery storage, they've proven time and again they can scale complex technologies. Optimus is simply the next step in a larger ecosystem of AI, autonomy, and energy. Would you be willing to spend $20,000 on a robot like Optimus? Please share your opinion in the comments section below this video.
So even, let's say, people are asleep, but you can deliver packages in the middle of the night or resupply restaurants or whatever the case may be, whatever people need at all hours of the day or night.
Just days ago, Tesla slipped out new images revealing Optimus's latest ARM architecture. Blink and you'd miss it. There was no press release, no splashy video. Yet the change is huge. An ARM 25% lighter, markedly more precise, and able to dial in force for each microphase of a job. Imagine Optimus watching a single how-to clip on motorcycle engine repair, then grabbing a wrench, tearing the block down, and rebuilding it flawlessly. No other robot can touch that. As Elon Musk loves to point out, while most bots are hard-coded or teleoperated, Tesla bot teaches itself at breakneck speed. Hand it a couple of YouTube videos and it can absorb 100 fresh skills per day, from tuning fuel injectors to swapping spark plugs, without ever forgetting or repeating a mistake. Now, Optimus Gen 3 is no longer a lab prototype. It's poised to walk straight out of the Texas facility. So why is Elon Musk rolling this out under the radar? Why does the laser focus on perfecting those hands? What sets the all-new design of Tesla Bot Gen 3 apart?
Our next generation has 22 degrees of freedom. It will be able to play the piano. So it's really like, wow.
The newly revealed shoulder and arm system in Tesla Bot Gen 3 marks a major breakthrough in humanoid robotics. Replacing the older dual-hinge design, this new architecture introduces a true ball-and-socket joint with an integrated harmonic drive, offering seamless 3 degrees of freedom. This enables the arm to reach into tight spaces and maneuver with precision from virtually any angle, vastly expanding its functional workspace. At its core is an ultra-compact harmonic drive nested inside the joint, delivering high torque density with near-zero backlash while reducing actuator mass by over 25%. Its regenerative braking captures kinetic energy, improving energy efficiency and extending operational time. Encircling the joint are embedded sensors, measuring force, torque, and motion, allowing millisecond-scale feedback control. This gives the bot the dexterity to handle fragile components and the strength to manage heavy loads, switching between tasks effortlessly. All power, data, and pneumatics are routed internally, protecting sensitive systems and simplifying maintenance. A lightweight magnesium-aluminum composite shell reinforced with carbon fiber further reduces weight by 25%, cutting inertia and boosting agility. This allows Gen 3 to carry up to 7 kilograms with the same fluidity as earlier models did with 5 kilograms, while improving cycle efficiency by 20%. The smooth, sealed exterior and compliant mechanisms also enhance safety in human environments. Altogether, this design isn't just an upgrade, it's a leap forward. It empowers Tesla Bot Gen 3 to perform high-precision assembly, logistics handling, field labor, and domestic support with exceptional mastery, positioning it as a new standard for scalable, human-centric automation. Optimus is equipped with Tesla's advanced neural network and computer vision system. Thanks to Tesla's neural network, Optimus can learn and perform complex tasks just by watching them once, and it can relearn anything incredibly fast. It might sound unbelievable, but one day when you own an Optimus, you'll simply show it a video of your favorite musician playing a song. The robot will analyze every hand movement, chord, and rhythm. Then it'll guide you step by step in a completely natural way, almost like learning from a personal teacher.
Get to the point where it can watch a video of something like a person and then learn just by looking at that video and do that task.
To carry out all these tasks beyond having a brain to process information and store data, Optimus also has one crucial component: its special hands, dubbed the best robotic hands in the world. A fun fact is that a robot can still be useful without legs, but without hands, it's just a useless metal shell. In reality, many tasks require humans to stay seated with limited movement, making hands even more essential than legs. While Optimus currently moves at about 2 miles per hour, a fairly slow pace, it's the robot's precise, skillful hands that deliver unmatched accuracy and capability, setting Tesla apart from all its competitors. Elon Musk mentioned that Optimus's hands are among the most labor-intensive components for the engineering team. The actuators and sensors were all custom-built from the ground up based on fundamental physics principles. Specifically, the hands, from the elbows down, received the most technical focus and refinement. With around 8 2D cameras and ultra-sensitive sensors, imagine a robot that can serve as a dedicated guardian, patrolling your home. The Tesla Bot's vision system operates with the same level of precision as the technology in Tesla vehicles, allowing cars to detect and avoid obstacles on the road. This gives Optimus the ability to analyze and recognize everything around it with high accuracy. As it moves through your home, it can easily identify and navigate objects like pets, furniture, or any other obstacle. In more complex industrial environments, like a massive Tesla factory filled with machinery and assembly lines, Tesla Optimus can leverage this technology to optimize terrain recognition, map out spaces, and glide smoothly through obstacles, ensuring both efficiency and safety. Why did Elon Musk decide to upgrade this design in Tesla Bot Gen 3? The evolution of the Tesla Bot's ARM design from Gen 2 to Gen 3 represents a dramatic leap in both the number and sophistication of tasks that Optimus can perform, a transformation that becomes especially clear when we consider the hands at the end of those arms. In the Gen 2 iteration, Tesla introduced hands with roughly 11 degrees of freedom, which already outstripped most competitor robots, but still left significant gaps in dexterity. These early hands were capable of grasping objects, operating a simple computer interface, and performing basic household tasks like folding clothes and watering plants. Yet they lacked the nuanced control and tactile feedback necessary for more delicate operations. Threads might slip, or small tools could be dropped, and certain motions simply felt too clunky to be trusted outside of a laboratory demo. With Gen 3, Tesla has rebounded from those limitations by engineering what Elon Musk has called the best robot hands in the world, boasting 22 degrees of freedom that more closely mirror the complex biomechanics of the human limb. The actuators and sensors have been completely redesigned, building a sealed, waterproof enclosure that protects internal circuitry while providing enhanced haptic sensitivity at each fingertip. This means that the same robotic hand that can firmly grip and unscrew a jar lid can also gently handle an eggshell, thread a needle, or press piano keys with precise force, all without changing hardware. As a result, Gen 3 Optimus can tackle a far wider array of tasks than its predecessor ever dreamed of attempting. Where Gen 2 could navigate stairs, carry heavy trays, and load a dishwasher, Gen 3 has graduated to multi-step routines requiring simultaneous force modulation, fine motor coordination, and real-time feedback. In recent demonstrations, Gen 3 not only emptied trash bins and folded laundry, but also organized cutlery by shape and size, pruned fragile houseplants, and even performed simple surgical-style stitches on fabric samples, showcasing capabilities that would have been inconceivable for the previous version. What enables this transformation is the marriage of advanced mechanical design with Tesla's AI-driven control algorithms. The new hand integrates 8 high-resolution cameras within the wrist and palm, feeding visual and depth data into the FSD-derived computer vision system. At the same time, each joint houses force sensors that continuously relay pressure and position information to the neural network. This closed-loop feedback allows Gen 3 to adapt its grip in milliseconds, compensating for slippage or unexpected resistance. Beyond household chores, the Gen 3 ARM upgrade extends Optimus's utility into industrial and service sectors in ways the Gen 2 simply could not achieve. In factory environments, Gen 3 can swiftly pick and place small components on assembly lines, handle delicate glass or ceramic parts without fracture, and operate standard power tools, tasks that previously required human intervention or specialized machinery. The hand's increased range of motion and power density also make it possible for Optimus to assist in healthcare settings, where it can hold surgical instruments, administer medication vials, or even operate simple diagnostic devices under supervision. Such versatility speaks directly to Elon Musk's vision of a humanoid robot that is more useful than a car, as the ability to perform high-precision tasks transforms Optimus into a genuinely multifunctional workforce assistant rather than a narrowly focused prototype. Crucially, Tesla's emphasis on scalability and cost efficiency means that these ARM improvements do not come at prohibitive expense. By leveraging the same 4,680 cell technology used in Tesla vehicles to power onboard electronics, Tesla Bot Gen 3 integrates compact high-energy power modules within the forearms themselves, eliminating bulky external battery packs and reducing overall weight. The streamlined wiring and snap-fit actuator modules simplify manufacturing, enabling Tesla to retain its aggressive target price point of around $20,000 per unit. This economy of design ensures that organizations seeking to deploy fleets of Optimus bots, whether in warehousing, retail, hospitality, or elder care, can justify the investment through measurable productivity gains rather than writing off the robot as an R&D curiosity. What truly distinguishes the Gen 3 ARM, however, is not any single hardware innovation, but the cumulative effect of incremental improvements that collectively elevate both performance and reliability. From native AI motion planning that anticipates user intent to hot swap modular joints, allowing rapid field replacement, every aspect of the ARM has been optimized to maximize uptime and minimize maintenance downtime. The result is a platform that can learn new tasks through video demonstration, refine those skills through iterative practice, and then generalize them across different work environments, all while preserving the tactile finesse required for delicate operations. In sum, the Gen 3 ARM redesign transforms Tesla Bot from a limited proof of concept into a genuinely versatile agent capable of performing thousands more unique tasks with far higher precision and speed. By doubling the degrees of freedom, embedding advanced sensor arrays, and marrying it all to Tesla's AI and battery innovations, Tesla has redefined what humanoid robots can achieve, ushering in a new era where Optimus is not merely a walking torso, but a dexterous partner ready to handle the full spectrum of human chores and challenges. What have Elon Musk said about producing Gen 3 with the new design? Elon Musk has made it abundantly clear that the Tesla Bot Gen 3 represents far more than a mere incremental update. It is the centerpiece of Tesla's ambition to redefine not only mobility, but the very nature of labor itself. From the earliest public demonstrations of Optimus to private remarks shared with engineering teams, Musk has positioned Gen 3 as the turning point at which humanoid robotics will leap out of the research lab and into the mainstream. He has repeatedly stressed that reworking Optimus's design was one of the most challenging parts of the process, acknowledging that achieving a form factor suitable for mass production required more than a tinkering around the edges. Instead, it demanded a ground-up redesign. Every actuator, every joint, every millimeter of wiring had to be reconsidered in light of manufacturability, cost, and reliability. Musk doesn't mince words when he says that the success of Gen 3 will be measured not in lab prototypes, but in the tens of thousands of robots rolling off the assembly line. Earlier this year, Tesla quietly completed the first Gen 3 prototype, a machine born from more than 1,000 unique components assembled at the Fremont factory. Musk celebrated this milestone by describing Gen 3 as the version that really has the potential to deliver a wide range of tasks, and hinted that it would be unveiled to the public as early as the first quarter. This unveiling, he has explained, will not be another Investor Day showcase confined to a polished stage. It will be the debut of a product genuinely ready for real-world testing, complete with the refinements, waterproof hands, optimized drivetrains, advanced power management, that differentiate it from its predecessors. He has emphasized that every day Tesla adds new updates to Optimus, but it is with Gen 3 that the robot will move beyond incremental demos and become a scalable, deployable solution. Production targets for Gen 3 are nothing if not audacious. Musk has disclosed plans to produce 5,000 units by the end of this year, with parts already in place for 10,000 to 12,000 robots. He candidly admitted that success would be defined by achieving half of that volume. Even 5,000 robots is the size of a Roman legion, he quipped, conjuring images of mechanical cohorts poised to transform the workforce. He then added that the real triumph would be repeating that feat literally next year, when Tesla would aim to roll out 10 legions, or roughly 50,000 robots. In subsequent remarks, Musk projected an exponential ramp, between 50,000 and 100,000 units by 2026, surging to 500,000 or even 1 million by 2027, and ultimately scaling to 1 billion plus per year as global demand takes hold. Such numbers, while staggering, reflect Tesla's confidence in its integrated manufacturing ecosystem, an ecosystem that leverages gigafactories, in-house battery production, and shared components with electric vehicles to drive down costs and accelerate output. Tesla's strategy for bringing Gen 3 to market is as bold as its production targets. Internally, the company plans to deploy 1,000 Optimus units across its own factories this year, embedding the robot into production lines to handle tasks like arranging 4680 battery cells and material handling. Musk views these internal deployments as both a practical necessity, testing reliability under continuous operation, and a powerful proof point that will convince customers of Optimus's real-world value. By 2026, he has stated, Tesla will open robot sales to consumers, accompanied by a rental program for businesses seeking flexible, on-demand robot labor. This two-pronged approach, factory integration followed by commercial rollout, underscores Musk's belief that robots will first prove their worth behind the scenes before becoming household fixtures. Throughout his public statements, Musk has returned to a single resonant theme. Gen 3 is Tesla's most important product. He argues that while cars remain parked most of the time, Optimus will be active for hours each day, performing chores, manufacturing, caregiving, and even potentially supporting space missions. He envisions a future where each person owns at least one robot companion, and where Tesla's valuation soars to $25 trillion on the back of these mechanical colleagues. His unabashed prediction that Optimus will outsize every other Tesla product by a factor of 10 speaks to the confidence he places in Gen 3's design innovations and Tesla's ability to scale. Critically, Musk has framed Gen 3's success not merely in terms of hardware, but as a systems achievement. He emphasizes the synergy between Tesla's 4680 battery technology, its full self-driving computer vision stack, and its factory expertise. Do you think Tesla Bot Gen 3 could really become more essential than a car in everyday life? Why or why not? Please share your opinion in the comments section below this video.
In fact, you really won't even need to, it'll figure out what you probably want and do what you probably want without you even having to ask.
By 2035, we'll be short about 75 million workers, which means big gaps in jobs like elderly care, delivery services, and construction. Meanwhile, Figure 01 lacks large-scale production data. Digit V4 from Agility Robotics may walk on 2 legs and serve as a warehouse bot for Amazon, but its dexterity is limited. Sanctuary's Phoenix V3 has soft hands, but suffers from a high burnout rate and subpar safety standards. In contrast, Tesla's Optimus Gen 3 has completed its initial pilot production phase. With Dojo-powered data systems ready to go, it's preparing to hit the market at an estimated cost of just $20 per hour, with the ability to operate 24/7 and potentially break even within just 18 months. Each software update brings new at-home capabilities, cleaning today, fixing a leaky pipe tomorrow. And just recently, Tesla's viral household demo of Optimus captured the public's imagination, offering a clear reason for Elon Musk's confidence when he said,
Who wouldn't want their own personal C-3PO R2-D2? I think that's a reasonable target.
So why exactly is Elon Musk so confident about the latest version of Tesla Bot Optimus Gen 3? What updates are coming soon? How much will it cost? And will we really get to welcome these robots into our lives, just as promised? Let's dive deeper in today's episode. So, how is the Tesla Optimus Gen 3 being shipped?
It's going to grow very fast. I think humanoid robots will be the biggest product ever. The demand will be insatiable.
Just 2.5 years ago, Tesla's very first Optimus robot took its shaky first steps on stage during AI Day 2022. At the time, many critics didn't believe it would ever make it out of the lab. But Elon Musk stood firm, saying that humanoid robots would become the biggest product ever and that the demand for them would be insatiable. Now, fast forward to April 23, 2025. In Tesla's latest shareholder letter for the first quarter, a photo showed 9 shiny Optimus Gen 3 robots lined up on an assembly line at the Fremont factory. The caption was short and sweet. Optimus pilot production line now online. But during the earnings call, Musk gave more details.
But we expect to have several thousand Optimus robots produced and doing useful things by the end of next year in the Tesla factories. And then in 2026, ramping up production quite a bit. At that point, we'll be providing Optimus robots to outside customers.
Tesla has also officially confirmed a plan to build 5,000 robots in 2025. This will serve as a kind of stress test within the company before opening up orders, first for businesses and later for everyday people and families. At the same time, a video went viral on X, showing the Gen 3 robot doing real household chores, stirring a pot on the stove, vacuuming the floor, and wiping crumbs off a kitchen counter, things that would have knocked earlier versions off balance. Elon Musk didn't hold back, calling Optimus Tesla's biggest ever product. The public reaction came fast. While other home robot companies like Figure, Agility, and Sanctuary had only shown carefully staged lab demos, none had released unedited footage of their robots working in a real home. The general feeling? Tesla's Gen 3 had taken a major step forward, finally crossing that tricky line between cool idea and something truly useful in everyday life. How is Tesla Bot Gen 3 learning through video imitation and self-play?
Yeah, it's going to take a lot of compute resources, and it'll take time. I think there's certain threshold breakthroughs that we think we can achieve, where if Optimus can watch videos, YouTube videos or how-to videos or whatever, and based on that video, just like a human can, learn how to do that thing, then you really have task extensibility that is dramatic, because then it can learn anything very quickly. So I think we'll get there.
Elon Musk recently talked about what he called a very important breakthrough: the idea that a robot like Optimus could learn just by watching a video. He explained that if Optimus can watch a task on YouTube and then do it on its own, the number of things it could learn would skyrocket. In his words, task extensibility becomes dramatic. It can learn anything very quickly. At one time, that might have sounded like science fiction, but now it's starting to feel surprisingly possible.
XAI is building the most powerful. We have the most powerful. I think we have the most powerful training cluster in the world right now, which is over 200,000 GPUs training coherently.
One of the critical pieces of technology is an AI model that understands the world. Just as we have an AI model that understands language now with ChatGPT and Llama and such, we need a world model, a language model of the world.
Unveiled at Consumer Electronics Show 2025, NVIDIA's Cosmos is a breakthrough in robotics and AI, a suite of what they call world foundation models. These models are trained on millions of hours of driving and robotics footage, and they don't just recognize objects, they understand the real-world physics behind them. Everything from gravity to friction to inertia is built into their reasoning. That means Cosmos can generate lifelike, consistent behavior over time, whether it's used in simulations or directly powering robots through AI decision-making networks. NVIDIA CEO Jensen Huang even called it the missing language model of the physical world, a bold claim that has quickly gained traction. One of the most impactful aspects of Cosmos is that it's been released under an open model license. That gave Tesla the chance to fine-tune it, using its own massive data trove gathered from its global fleet of vehicles and robots. The result is a highly efficient hybrid model, specifically tailored for robotics, that learns faster and performs better than anything before it. Backed by Tesla's powerful Dojo supercomputer, the system can now absorb tens of millions of real-world scenarios each night. When a new policy, a kind of learned behavior, passes a series of safety checks, it's immediately sent for hands-on testing at the company's Fremont factory. And the results have been impressive. Internal reports say that Tesla's Optimus Gen 3 robot now only needs about 40 minutes of guided training to handle a brand new object, whether it's something as everyday as a kettle or a tricky item like a dog leash. In May 2025, a now viral video posted on X showed Optimus Gen 3 performing household tasks in a real Tesla staff member's home, not a carefully staged set. The robot successfully used 5 different tools, including a vacuum, mop, spoon, pan lid, and dustpan, all without falling or making any critical errors. Meanwhile, at the Fremont facility, early versions of the robot have been sorting interior clips for the Model Y at a rate of 23 items per minute, approaching human speed. Even more exciting, the robots are recording ergonomic data to help design better joints and movements for future generations. In simulated training, the progress has been just as dramatic. A batch of 500 Optimus bots running in virtual self-play managed to complete a shape-sorting task with 98% accuracy after just 16 CPU hours, an 80-fold speed improvement over the same task last year. Taken together, these breakthroughs make Elon Musk's famous comment, "You really won't even need to figure out what you want. It will probably know," feel a lot less like science fiction and a lot more like the near future. Why can Tesla Optimus Gen 3 perceive as an independent human? The proximate cause is the scale and architecture of the computer backbone Tesla and its sister company, xAI, have erected in Memphis. On 21st May, 2025, Elon Musk confirmed that Colossus, a repurposed distribution warehouse on President's Island, is already humming with roughly 200,000 B-class and AMD MI300X GPUs, delivering an estimated quarter exaflop of mixed precision throughput, 4 times the peak rating of the US DOE's Aurora supercomputer. While the figure is staggering in isolation, the strategic intent becomes clear in light of the construction permit filings Business Insider unearthed last month. A second hall, equal in footprint, is being outfitted to take the complex to 1 million GPUs by late 2026, backed by a dedicated 500-megawatt substation and $400 million in new transmission infrastructure. That electrical draw places the site in the same utility class as a primary aluminum smelter and exceeds the combined IT load of Meta's Printerville and Google's Council Bluffs campuses. Tesla's in-house Dojo V2 nodes, built around a custom systolic array that excels at low-precision convolutions, are still on the payroll for perception pre-training and value function rollouts. Yet Musk's procurement rule is brutally simple. If NVIDIA is ahead, we buy NVIDIA. The result is a heterogeneous mesh in which visual contrastive learning runs on Dojo tiles approximately 0.34 joules per teraflop. Trajectory diffusion models grow on Blackwell GPUs, approximately 0.42 joules of energy, consumed for each teraflop of computation, and critic simulations execute on power-hungry but memory-rich MI300X boards. Router telemetry presented at a recent IEE Hot Interconnects workshop showed aggregate ring bandwidth of 24 petabytes per second, enough to shuffle the entire ImageNet corpus across the fabric in a third of a second. Why field an array that seems oversized even by hyperscale standards? Consider the data budget. A single 60-second training episode for Optimus, HD stereo video at 120 Hz, depth maps, 72 proprioceptive channels, 6-axis inertial measurement unit and spatial audio, occupies around 18 GB uncompressed. Tesla's current overnight curriculum generated by Omniverse emits roughly 12 billion such episodes every 24 hours. Feeding that torrent through a transformer stack with a 4-second temporal context demands close to an exaflop of sustained AI FP8 if policy refresh is to complete before the next day's shift begins. At the 48,000 GPU scale Meta disclosed for Llama 3, a single curriculum pass would stretch to 9 days, unacceptable when Fremont's body shop robots are waiting for a Monday morning firmware update. Energy cost is the governing constraint. Colossus Phase 1 operates at a power usage effectiveness of about 1.12, owing to direct-to-chip warm water loops. Every tenth of a PUE point recovered saves on the order of $25 million in annual electricity at Tennessee Valley Authority tariff levels. Internal cost models place Tesla's blended expense at 83 cents per billion tokens of embodied AI training, versus roughly $1.45 on equivalent cloud. 100 allocations, a 43% delta that compounds across trillion token schedules. Competitively, the gulf is widening. Meta's dual 24,000 GPU clusters, Google's estimated 75,000 unit TPU v6 pod, and Microsoft OpenAI's putative 100,000 GPU Azure array all target text-centric corpora. Humanoid control is 3 to 4 times heavier in sensory bandwidth, so compute headroom converts almost linearly into behavioral diversity. Early field telemetry bears this out. Gen 3 now masters an unseen household tool, say a stovetop kettle, in about 40 minutes of supervised fine-tuning, down from 5.3 hours on Gen 2, and hits 23 part picks per minute on the Model Y line while keeping joint motor-specific energy below 10 watts per kilogram. The conclusion is straightforward. Independent agency in robots is not an emergent mystery. It is a scaling law. By committing to a 1 million GPU footprint and a hybrid Dojo-Blackwell-Rubin pipeline, Tesla has secured the computational substrate that turns raw, unlabeled sensor torrents into policies that approach the fluidity of human motor learning, but evolve at silicon speed. In this regime, what looks like excess is merely the minimum viable cost of teaching a silicon workforce to improvise in a world built for flesh and blood labor. How did Elon Musk confirm the production timeline of Gen 3? 23rd April. 2025 factory tour revealed that Tesla has carved out a dedicated 2,000 square meter high-mix, low-volume wing inside the Fremont Plastics shop to pilot-build Optimus Gen 3. Within this area, 6 tightly choreographed work cells handle the entire mechanical flow. A 6-axis automated fiber placement head followed by an autoclave lays up each carbon fiber femur in 210 seconds, while holding a 98.7% yield. Nearby, a 4-kilowatt fiber laser welds torque-dense harmonic drives, rated at 15 Newton-meters per kilogram, into the hip housings in 180 seconds, with 97.9% first-pass success. A third station outputs the 700-volt spinal power bus in 130 seconds at just over 99% yield. And the end-of-line rig uses structured light vision and a capacitive fixture to calibrate fingertip force sensitivity to within plus or minus 0.3 Newton, achieving a 99.6% acceptance rate. Although engineers estimate that more than 80% of mechanical parts are unique to Gen 3, the AI computer, cooling manifold, and 4680-based batteries are lifted directly from the Model Y bill of materials, preserving vendor continuity and existing PPAP approvals. The line's current takt, about 500 robots per month, roughly twice. Boston, Dynamics-AQ Industrier Herr Kreisherr 2024 spot output offers Tesla ample capacity to validate tooling and processes before shifting high-volume production to Gigafactory Texas in late 2026. Capacity allocation disclosed during the May earnings call targets 300 bots in the third quarter across Tesla's Fremont, Austin, and Berlin for pick-and-place logistics, followed by 2,000 units in the fourth quarter dedicated to parts kitting. Internal time and motion studies show Gen 3 already hits 23 picks per minute on Model Y clip trays, within 18% of a trained human while logging wrist torque spectra for gearbox redesign. Deployment remains in-house until statistical MTBF tops 4,000 hours. Only then will Tesla lease ex-factory robots to Tier 1 suppliers that already reside on Gigafactory campuses, minimizing field service overhead. To avoid the kind of messy integration issues that slowed down earlier industrial robots, Tesla plans to release version 0.9 of the Optimus software development kit around the middle of the year 2026. This update will include a user interface that makes it easier to manage tasks, set up feedback systems, and create safety zones that users can define themselves. At first, the testing slots will go to companies that already run Tesla's energy storage systems, so that the same maintenance teams can look after both the energy packs and the robots. According to the early documentation, the robots' behavior updates are relatively small, less than 150 megabytes, and can be downloaded wirelessly and run on the same computer chip used in Tesla's self-driving cars. This helps make everything simple and smooth for business partners. Looking ahead, Elon Musk is aiming to eventually sell each robot for about $25,000. That would require Tesla to bring down the cost of making one to around $17,000, leaving room for about a 35% profit margin. Right now, though, building a single test unit still costs close to $118,000. Most of that cost comes from high-precision motor parts, advanced carbon fiber components, and complex wiring systems. Do you think having a robot that just knows what you want is exciting or a little bit scary? Would you feel comfortable having an Optimus bot in your home? Please share your opinion in the comments section below this video. Thanks for watching our video. If you want to explore more exciting information about Tesla EV or Tesla Bot, Don't forget to hit the like button and share this video. Also, make sure to subscribe to Tesla Car World and turn on notifications so you never miss our latest videos. We appreciate your support and look forward to seeing you in the next video. Goodbye.